Yeah, good morning. We also want to talk about sprayer calibration. When we are applying herbicides, it is critical to know the amount which is being sprayed. Otherwise, it may lead to over application of the herbicide or under application. With under application, we are not able to control the weeds. With over application, we can introduce uh, herbicide residual problems, which may affect our crop rotations. So let us discuss or talk about sprayer calibration. So application of herbicides require that the sprayer has to be calibrated. For herbicide application, you may find that the herbicide rates or dosages are in mils or liters per hectare. For example, Lynx 120 SR, you now know what SR means. Uh, it's a broad spectrum herbicide for use on soybean and groundnuts, and the rate could be 300 mils per hectare. So, how can we possibly distribute 300 mils of Lynx 120 SR? SR means soluble liquid. So we have to make so the herbicide is mixed with water and is sprayed via the nozzles. The objective is to determine the amount of water required to spray 1 hectare, which is spray rate. So when we are calibrating a sprayer, our task is to determine what we call the spray rate or amount of water which should cover 1 hectare. So this is a Knapsack CP15 or a Knapsack sprayer, which has got a container, a handle for pumping. Then this is the lance. This is where you get your output. So what is calibration? It is adjusting a sprayer to give it a specified output or spraying per unit area, usually 1 hectare. Herbicide is then suspended in the spray volume. For example, application rate for atrazine, it could be 4 liters per hectare applied in 200 liters of water. Why calibrate? Why not just apply? To achieve uniform herbicide application requires that the sprayer has to be calibrated. Effects of over application versus under application. Herbicide activity is dosage dependent, so there's a need to calibrate. Factors that affect sprayer output are speed of the operator, pressure, that is from the pump, nozzle size, height of the nozzle above the ground. These are types of nozzles. This is the first one, it's a hollow cone nozzle. This is suitable for spraying insecticides, not herbicides. This one is information on the nozzle tips where we have the reference or tip reference. You may have 01 dash F65, 01 dash F80, 01 dash 100, or it could be 02 F65, 02 F80, 02 F100. What do these mean? 01 indicate the size of the orifice. So it can vary between 0.1 or 0.2. 80 indicate angle of discharge. And the F indicates that the nozzle is a flat fan and it requires overlapping. So orifice sizes could be 01, 0.15, 02, 03, and 04. And this reflects the amount of water which is discharged or liquid. Flat fan nozzles. These are commonly used for herbicide application. And you have this indicating the orifice size 01 and 80 and 110. Here it's angle of discharge. So nozzle tip information. So you can have this nozzle code written like this: 80 EF02 yellow. This means even flat fan if there's EF. 02F80 yellow, this may mean flat fan. Spray angle is 80. 02 represents the discharge, amount of liquid which is coming through the nozzle. So this is the codes. So if you want a nozzle to spray herbicides, you should understand these codes. But sometimes if you go into town and try to look for these nozzles, you may not find these specifications. Flat fan nozzle, this is how it looks like. So this is the spray pattern coming out of this flat fan nozzle. Flat fan nozzle spray pattern, you've got your flat fan nozzle here, and when you spray, you have this angle, which can be 65 or 80 degrees. And when the spray hits the ground, it creates this shape. And we say the shape has got two tapered ends, this one and that one. If you spray on a dry surface, you can see this shape. So if you are using these nozzles on a tractor boom sprayer, you may need to make some adjustments so that you have this overlap, so that you don't have areas where you under apply, especially at the edges. If our next nozzle was coming right from here, it means this area will be under applied. So we need the spray pattern to overlap like this. Even spray flat fan, these give uniform spray across the entire width of the fan. It is recommended for bend spraying. Sometimes you just want to spray along the crop row. this could be the ideal nozzle for that. So this is the even spray flat fan for bend application. You can see it doesn't have a tapered end. So this is the spray pattern for flat for even spray flat fan. And at the end, it is straight. You don't have a tapered edge. This is a flat jet nozzle. This gives a wide swath, or you can cover a big area when spraying. So sprayer calibration, you need a stopwatch, measuring tape, and a measuring cylinder. So these are the steps to follow. You have to select your nozzle from a wide range of nozzles, fill the tank with water, and operate the pump to maintain a pressure of 1.4 bars. You know, some of the sprayers do not have a pressure gauge, but it may be necessary to fit one so that you know the amount of, so that you know the pressure which at which you are operating. Height of the nozzle tip from the ground should be constant. So what we do, we tie a string and a weight so that this gives you an idea about the height at which the nozzle should be maintained, because we want the height to be constant. But some experienced applicators may not require this uh, string and weight to guide them during spraying. Uh, what you may do is to spray a dry surface so that you determine what we call the swath or width of the spray. So this is the width of the spray. Remember to offset this part here, which is the tapered end. When you want to take your swath or width, don't start at the end here. Otherwise, this area will be under applied. Now walk for a distance of 30 meters while pumping the sprayer steadily and determine the time taken to cover 30 meters. You have to repeat this 3 times and then find the mean. Using time required to walk a distance of 30 meters, then determine the amount of water which is delivered by the knapsack and measure it. Do it 3 times and find the mean. The alternative method could be that you just fill the sprayer with a known volume of water, e.g. X liters. Then you spray a distance of 30 meters, walking with a speed of 1 meter per second. Then the remaining water after spraying, you empty the sprayer and then measure it. It could be Y liters. Then you may get what you have applied to the 30 meters by subtracting X liters, the initial, minus Y, the final liters, will give you the amount which has been sprayed to cover 30 meters. Probably you need again to repeat 3 times, then you get the mean. So the data which you now need is swath width or width sprayed in meters, the distance traveled during spraying, e.g., 30 meters, time taken to walk 30 meters. If your speed is 1 meter per second, normally it is 30 seconds. Amount of liquid sprayed when walking 30 meters in liters. 30 meters in liters, right? Okay, this is the summary of the data collected. The swath, it's in meters. Time taken to travel 30 meters, it's in seconds. Mean volume delivered in liters. Area sprayed. Now it's going to be the swath multiplied by distance, and this gives you square meters. Remember, swath, spray dry surface, then measure the width. Now, we need some calculations to determine the spray rate. So, what is the spray rate? Or what is the amount of water required to spray to spray 10,000 square meters or 1 hectare? So by simple proportion, you will say 30 meters times swath width square meters require the mean volume in liters, the one which you have determined. Therefore, you want to determine how much water will be required to spray 10,000 square meters or 1 hectare. This will be mean volume liters times 10,000 square meters divided by the area which you covered when calibrating the sprayer, 30 meters times swath. I hope this is clear enough. So this is someone spraying. This is the swath, and this is the distance. Now, example which we can use, we can have a swath width 1 meter, distance covered by the spraying, it's 30 meters, time taken to walk 30 meters, it's 30 seconds, amount of liquid sprayed when walking 30 meters, it could be 0.55 liters. Probably this was taken during a practical. Amount of liquid applied per hectare, it's now 0.55 times 10,000 divided by 30 meters times 1 meter, which is the area. And we now have our spray rate as 183 liters per hectare. But on average, it could be 200 liters per hectare. If it is more than 200 liters per hectare, maybe you need to change your nozzle. In fact, if you have nozzles which discharge above 300 liters per hectare, there's a lot of labor required, in carrying water and mixing. Now, we may want to know the amount of herbicide which is required for mixing. For example, we want to apply MCPA at 300 liters per hectare. The question is, how much herbicide do we need to mix with water for a 15-liter Knapsack sprayer? So volume of the herbicide, it will be 3 liters times 15 times 1000 divided by 183, which comes to 246 mirrors, is the amount of MCPA which we are going to measure and put into our knapsack sprayer. So what we do when we have measured 246 mirrors, we put a bit of water in the knapsack, then we add 246, then we fill the knapsack up to 15 liters and make sure there is mixing. We have to mix. But MCPA may be, it may easily form a solution. It could be an SR formulation. Well, this is just an example where we have in a test run a measured course of 110 meters length is found to require 54 seconds for traveling forward and 56 seconds for returning to the starting point. The spray carried a tank of 400 liters capacity and 12 nozzles boom with the nozzles 50 centimeters apart. After completion of the test run, it was found that it consumed 45 liters of water from the tank. Anyway, this example is about a tractor boom sprayer which is being calibrated with the 12 nozzles. If you want to know the boom, if you want to know the swath, you multiply 12 nozzles times 50 centimeters. But otherwise, the calibration is more or less the same. So this is just an example where we also have a solution about this example of how to calibrate a sprayer. Again, it's another example. So this is actually it for knapsack sprayer calibration. So I will have to stop here.